Analyze the particulate representation of vessel 1. KCl vessel 1 represents an aqueous solution of KCl. KCl is a strong electrolyte that dissociates completely into its constituent ions in water. KCl gives K to the power plus Cl to the power negative, counting the ions shown in vessel 1. Positive ions, K to the power plus, represented by black circles 5 particles. Negative ions, Cl to the power negative, represented by white circles 5 particles. This represents a 1-to-1 ratio of cations to anions, maintaining electrical neutrality. The molarity of this solution is proportional to the 5 formula units of KCl dissolved in this volume. Analyze the particulate representation of vessel 2. Counting the ions shown in vessel 2. Positive ions, black circles 10 particles. Negative ions, white circles 20 particles. This represents a 1-to-2 ratio of positive ions to negative ions, 10 positive to 20 negative. Identify the chemical formula of the solute in vessel 2. Because the solution must be electrically neutral, the total positive charge must equal the total negative charge. A 1-to-2 ratio of cations to anions indicates that each cation must carry a +2 charge to balance 2 anions, each carrying a -1 charge, representing an XY2 salt. Between the given options, CaCl2 is a soluble ionic salt that dissociates in a 1-to-2 ratio. CaCl2 gives Ca to the power 2 plus 2Cl to the power negative. Therefore, the solute in vessel 2 must be CaCl2. Determine the relative molarity of vessel 2 compared to vessel 1. Both vessels contain equal volumes of solution. The molarity, M, of a solute is directly proportional to the number of formula units, or moles of the cation, dissolved in that volume. For KCl in vessel 1, molarity is proportional to 5 formula units, or 5 Kelvin to the power plus ions. For CaCl2 in vessel 2, molarity is proportional to 10 formula units, or 10 Ca to the power 2 plus ions. Comparing the concentration of the salts, molarity of vessel 2 over molarity of vessel 1 is equal to 10 over 5 is equal to 2. This indicates that vessel 2 contains a CaCl2 solution with twice the molarity of the KCl solution in vessel 1, identifying option D as the correct answer. The correct answer is option D, CaCl2 with twice the molarity of the solution in vessel 1.